Hello, in this video I'm going to show you how to calculate crystallite size from XRD data. Your crystallite size can be calculated using the Scherrer equation, where D equals to K alpha over L cos theta, where D is your average crystallite size, K is the Scherrer constant, typically 0.94 for spherical crystallite, and your alpha is your X-ray wavelength, which is around 1.5406 Armstrong. L is the line broadening at FWHM in radians, and your theta is your Bragg angle. It's typically half of 2 theta from the diffractogram. Let's quickly break down the structural hierarchy of materials and why crystallite size matters in XRD analysis. At the larger scale, we have particles, which are made up of multiple grains. Each grain contains smaller crystallite, and those crystallite are built from repeating unit cells, which themselves consist of atoms or molecules. So the hierarchy goes particle greater than or equal to grain, and grain or equal to crystallite, and crystallite greater than unit cell, and unit cell greater than molecule or atom. Smaller crystallite lead to broader XRD peaks. That's because when crystallites are tiny, there's more boundary disorder and less coherent scattering, which causes peak broadening in X-ray diffraction patterns. This relationship is crucial in material science because it helps us estimate crystallite size using the Scherrer equation and interpret how microstructure affects material properties like strength, transparency, and thermal stability. Now you copy your XRD data and paste it on Origin Pro. So you select the two columns, the X and Y axis, and then you plot. Now when you have these, you go straight to analysis, and then you click on peaks and baseline, and then you select multiple peak. You open the dialog. Now you can just go with the current peak function, which is Gauss. We are going to be selecting prominent peaks here, peaks that are very apparent. So I'm going to be starting with the most significant peak. You double click on it. I'm just going to leave this last one. Then it will fit the peaks. Now if you examine the peaks, you can see that the fit is reasonable. We have the R squared to be around 0.94, which is good. Then we click on yes. Now you scroll down, and then you will find the value, the 2 theta values. These are the 2 theta values, and you have your FWHM here. So you select those and take them to Excel for further analysis or calculation. Now in Excel, you just paste that here, and then you return back and copy the value for L, which is FWHM. And that's it. So you will convert the L in radian. So this is already converted. Likewise for the theta that you have, the 2 theta, you convert it to theta. So you just simply say D10 over 2. And for the cos theta, you should note that you have to put a radian to convert it to radian. When you're done, you are then going to consider the following. The formula, this is the general formula, right? And we already have our K, our constants, and the alpha, which we picked the value 1.5406. and then you insert those in this formula, From there, you are going to have the following values here. Mind you, these are all in Armstrong. So to convert it to nanometer, you just divide it by 10, and that gives you the values. After getting this, then you find the average of these values. The average gives you the crystallite size. So the crystallite size for our material is 21.05 nanometers. Don't forget to like, subscribe, and if you have any questions, you can send them in the comments.